All right, we're gonna give this a shot. I hate that I'm not there. I really miss you guys more than you know. But I thought I'd try this, and I'm gonna do the notes, and you're gonna fill them in, and then Mrs. Gray will be there to fill in and answer questions if you need her to. But hopefully this is gonna work. We're gonna go through the notes for day 9, and we're gonna start with writing an exponential function, and it's an exponential function when it looks like this, when it looks like y equals ab to the x. And the key to know that it's exponential is that x is in your exponent, that the variable's in the exponent. That's what makes it exponential. And we're going to have 2 points, xy and xy. So I'm going to go ahead and label these. This is x, and this is y, and this is x, and this is y. Okay, so just so you remember which is which. And we're going to write these as 2 different equations. The first one, I'm using the example of y equals ab to the x. And so if I rewrite y equals ab to the x, it's almost like I'm there. I'm stuttering and making mistakes already. Y equals ab to the x. For this first equation, my y is 10, so I'm going to plug in 10 for y, equals ab to the x. My exponent for x is 1. That's my first equation. And then you write a second equation doing the exact same thing with the second set of numbers. So this time my y is 80 equals ab to the x, and then my x is 4. Okay, so take these points and plug in x and y in place of x and y in this function. That's the first step. Now the second step is that we are going to I'm trying to make sure I do this the right way. Take this equation, the first equation, and put it underneath the second equation. And so I have 10 ab to the first. And the way you know which equation goes under which one, the one with the larger exponent. Okay, the 4 is bigger than the 1. Since my exponent is bigger on this one, I want this one on top. And what I'm going to do is divide those two. So when I take 80 divided by 10, that gives me 8. A divided by a cancels each other out. And I've got b to the 4th over b to the 1st. Remember, when we divide variables with exponents, you subtract their exponents. So this is b to the 3rd. So I take whichever one has the larger exponent, I take the other one, go underneath it, and I divide. And I divide all those parts. Now I want to rewrite this so that they have the same exponent. And I can rewrite 8 as an exponent of 3 by writing 2 to the 3rd equals b to the 3rd. Okay, so what we've done before is we've rewritten numbers so that they have the same base. I'm rewriting these so that they have the same exponent. And then if they have the same exponent, that means their bases are equal. So 2 equals b, or b equals 2, because their exponents are the same, I know that that's true. Then what I'm going to do is I'm going to take that b and I'm going to put it in place of b of the second equation. So this now becomes 10 equals a, my b is 2 to the first. I know 2 to the first is 2. I want to get a by itself, so I'm going to divide both sides by 2. And I get a equals 5, or 5 equals a. So now I have my a and my b. I'm going to rewrite this exponential equation using a and b. So I have y equals a, which is 5, b, which is 2, and those are being multiplied, to the x. So my final formula is y equals 5 times 2 to the x. I know. I just saw some of you roll your eyes. And then you're looking at this and you're seeing my shadows and everything. You're like, I can't believe we're trying to do this on YouTube. I wish Mrs. Reisinger was here because then I could ask questions. But I'm just going to keep working a couple of these until they make sense. And then if they don't make sense, then you guys can talk to each other and compare notes. So take really slow, careful notes, and you can stop and pause and rewind. That's the beauty of the video. It's awesome. Okay, so I'm giving x and y to this and x and y to this. My first equation is I'm going to take this y equals ab to the x, and I'm putting in x and y in their place. So my y is 10, and that equals a times b to my x, which is 2. All I did was replace x and y for x and y in that equation. And I'm going to do the same thing with the second ordered pair. So my y is 25. That equals a times b to my x, which is 3. Now I'm going to divide these two, and which one goes on top depends on which one has the biggest exponent. And right now b to the third is a bigger exponent than b to the second, so this one's going to go underneath. So we have 10 equals a b to the second, and I'm dividing those. Okay, well, we can't really divide evenly 25 divided by 10, but I can simplify that. 5 goes into both of those, so that gives me 5 over 2. The a's cancel, and on the b's, 3 minus 2 is b to the first, so 5 over 2 equals b to the first, or b. So I've solved for b. I take my b value, and I'm going to plug it into this other equation. There's a lot of going back and forth and plugging things in. So this becomes 10 equals a times b, which is 5 halves, squared. That whole thing squared. And remember, when you square a fraction, you square both the top and the bottom. So this is the same as 10 equals a times 5 squared is 25, and 2 squared is 4. And you could rewrite this as 25 over 4a. That's probably what would look most familiar to you. To undo a fraction, we multiply by the reciprocal. So I'm going to multiply by 4 over 25 on both sides. That'll leave me a on the right hand side. Over here I'm going to put the 10 over 1. 4 times 10 is 40. 25 times 1 is 25. And that can be simplified because 5 goes into both of those. 5 goes into 40 8 times, and into 25 5 times. So my a is 8/5. So now if I'm going to rewrite this equation, this exponential function, with my a and my b, I have y equals my a, which is 8/5, times my b, which is 5 halves, to the x. And that's your final answer. Okay, and usually I skip these you try ones, but since we're doing this on video, and you don't have a chance to ask me any questions, I'm going to do this one also. So we have x and y and x and y. The first equation, I take y equals ab to the x, and I'm going to plug in 1 for x and 8 for y. So that gives me 8 equals a times b to the x, which is 1. For this second equation, my y is 32, and that's going to equal a times b to my x, which in this case is x squared. Again, b to the second is bigger than b to the first. You put the one with the smaller exponent underneath, and then I'm going to divide. Well, when I divide here, 32 divided by 8 is 4. The two a's are going to cancel each other out, and b to the second over b to the first, you subtract 2 minus 1, that gives me b to the first. So my b is 4. I'm going to plug that into the second equation so I can solve for a. So I have 8 equals a times 4 to the first. That means 8 equals 4a. 4 to the first is 4, and 8 times 4 is 4a. I'm going to divide both sides by 4, and my a equals 2. So now I'm going to take both of those and plug them into my exponential function. So I have y equals a, which is 2, times b, which is 4, to the x. And that's my answer. Okay, so that's for an exponential function. Make sure you follow that process. Your exponential function is always y equals ab to the x. You know it's an exponential function because the variable x is in your exponent. That's called an exponential function. Now you got to be really careful because this one, you'll get this down, you work some of these, and then of course we take it to the next notch and we do power functions. And a power function looks just a little bit differently. A power function is where your b is your exponent, is your power. Your b is your power. So for exponential, x is your exponent, and for power function, b is your exponent. They just sort of switch places. But the process is still pretty much the same. All right, so we're going to do the same thing. This time though, this is the function that I'm plugging stuff into. So I have x and y and x and y. So in my first ordered pair, I'm going to plug in 4 for y equals a times, now I do know what x is, x is 2 to the b. Okay, I'm going to do the same thing with this function. I'm going to plug in 10 for y equals, I don't know what a is, my x is 6, and that's being raised to the b. I'm going to take, the first one has smaller numbers than the second one, so that's the one I'm going to divide by. I have 4 equals a 2 to the b. Okay, now I'm going to cancel everything. This is when I divide 10 divided by 4. I can't really divide that, so I'm going to reduce it or simplify it. That gives me 5 halves because 2 goes into 10 5 times, 2 goes into 4 twice. The a's cancel each other out, and I can divide this and keep the exponent. 6 divided by 2 is 3, so this gives me 3 to the b. And I'm actually going to move this over and give myself a little space. This is 3 to the b. I'm trying to find out what b is. And remember, whenever we're trying to get to the exponent, I've got to get rid of the base. And to get rid of this base, I need to do a log base of the same number. So I'm going to do a log base 3 to the 3. But if I do that, I have to do a log base 3 to this side. That will let me cancel out my 3. And that gives me excuse me. I'm going to do change of base log of 5 halves over log of 3. Take the log of the main thing over the log of the base is going to equal b, because my log base 3 cancels out. I'm going to plug this in. I'm going to plug into my calculator log, and then in parentheses the 5 divided by 2 close parentheses divided by log of 3. And when you do that, I'm going to use a 4-digit decimal. I get 8.8340. That's my b value. So that's what I'm going to take and put in place of b here so that I can solve for a. When I put that in place of b, I have 4 equals a times 2, and then I'm going to raise it to that power to the 0.8340. And then I'm going to put in my calculator 2 to the 0.8340. And actually, what I can do is just go ahead and divide by that, 2 to the 0.8340. And over here I'm going to divide by 2 to the 0.8340. And you just put that in the calculator. 4 divided by, and then 2 raised to that power. And you're going to get 2.243 equals a. Literally, you're just putting those numbers in the calculator. And so my equation, remember I'm using this equation, is y equals 2.243 x times x to the b, which is 0.8340. And that, ladies and gentlemen, is actually a really fun answer. I know you guys love that. You're really excited about that, I can tell. Okay, take a deep breath. Roll your eyes, because I know you're doing that. Think, I don't know, I'm never going to be able to do this, and then you're going to go, I have to do this because I'm going to get a really good grade on my Unit 7 test so that I can raise all my other quiz grades. So I'm going to pay attention to the next couple examples. So this is xy, and this is xy. One step at a time. The first step is to plug this ordered pair into that equation. So where there's a y, I'm going to put a 6. I have an a. Where there's an x, I'm going to put a 4. And then that's raised to the b. And then I'm going to do the same process with the second ordered pair. I'm plugging in 8 for x and 15 for y. So that gives me 15 equals a times my x, which is 8, raised to the b. I'm going to take, this one's got smaller numbers, I'm going to put it underneath and divide. So 6 equals a times 4 to the b. I'm going to simplify 15 and 6. 3 goes into both of those. 3 goes into 15 5 times. 3 goes into 6 twice. The a's cancel. These have the same exponent, so I can divide their bases. 8 divided by 4 is 2, so this is 2. And again, I'm going to give myself some room. 2 to the b. In order to get to that exponent, I'm going to have to take the log base of whatever to get rid of this base. So I'm going to do, since that's a 2, I'm going to do log base 2 on both sides. That will let me get rid of this base 2 and just have b on this side. I'm going to do a change base here. It's going to be log of this big number, this big green number, so log my 5/2 over the log of my base, which is a log base 2. You're going to put that in the calculator. You put log, and in parentheses you got 5 divided by 2, close the parentheses, and then divided by log of 2. And I want you guys to actually put it in your calculator, make sure you do it right. And when you do, you should get 1.3219 equals B. That's the number I'm going to put in for B here to solve for A. So I have 6 equals A times 4 raised to the 1.3219. Trying to get A by itself, I'm going to divide everything by 1.43219. 4 to the 1.3219. These will cancel here, so I have A on this side. And so in my calculator, I'm going to put 6 divided by 4 to that power. And when you do that, you end up with 0.9600. So when I rewrite my power function, I have y equals my A, which is 0.96, times x to the b, which is 1.3219. And that would be your answer. Okay, since you're flying solo without me, I'm going to do another example so that you have it. I have x and y and x and y. First thing, power function is y equals ax to the b. You're going to have to memorize which one's power and which one's exponential. The exponential is the one where the x is the exponent, the power is where the b is the exponent. And the x and the b just trade places. But you have to get them right, because if you do the wrong one, then you get the wrong answer. That's really sad. Okay. I'm going to plug in this for y and this for x, so I have 8 equals a times 3 to the b. And then for this one, I'm going to have 17 equals a times 6 to the b. I'm going to throw this one underneath and divide. So I have 8 equals a times 3 to the b. I can't really simplify 17 and 8, so that's just going to be 17 eighths. The a's cancel. Since these have the same exponent, I can just divide the bases. 6 divided by 3 is 2, so this is 2 to the b. In order to get to the b, I need to do a log base 2 to get rid of this base. But if I do that on one side, I have to do it on the other. That'll cancel them here, so I have a b on this side. Now I'm going to do change of base. Log of this green thing, so the log of 17 eighths divided by the log of 2 of my base. Plug that in the calculator, and I get 0.6861 equals b. I'm going to plug this into the first equation so I can find a. So that gives me 8 equals a times 3 to the 0.6861. Divide both sides by 3 to the 0.6861. This is the exact same thing, so it cancels. I'll do it over here to the 0.6861. You just put in your calculator 8 divided by 3 to that power. And when you do that, you get 3.7647 equals A. So my equation is y equals my A value, 3.76, I'm going to round it to 3.765, times x to my b value, 0.6861. And that's your answer. Okay, so hopefully that's enough of those to get you through. We also have a way that we can do these on our graphing calculator to do an exponential or power model. Okay, these you're going to go to the regression. First thing you do is you complete the table. Okay, this is to create an equation given a set of data points, like in number 7. First, you fill the table in. This goes in L1 and this goes in L2. You do that by doing stat edit on your calculator. Plug these in. Okay, we've done that before. Then you go over to stat calc, and we're going to pick the right regression. If I'm doing an exponential regression, then when I get to calc, I'm going to do 0, which is expreg, E-X-P-R-E-G, that's the exponential regression. That's an exponential model. And we know that an exponential model is when x is in the exponent. So that's y equals ab to the x is an exponential model. If we're looking for a power model is, you go through the same process, but when you get to calc, instead of using 0 and doing exponential regression, you're going to do A, which is scroll down to A, which is a power regression. And remember that the model for a power model is going to be y equals a x to the b. That's where the b is your exponent. Okay, so if I plug these numbers in and then I do the x reg, it's going to tell you that my a equals 327.08, and it's going to tell you that your b equals 1.13, and it's going to tell you that this is the model. Your equation is going to be y equals my a, 3.2708, times b to the, or times, that is my b, 1.13 to the x. Okay, that's my exponential model for that data set. If I'm doing a power regression, I plug these in, I ask for the power regression, it's going to tell you this model, and it's going to tell you that A is 1 and B is 1.5. So to write the equation, I've got y equals A, 1 times x to the 1.5, which is my b, and that would be your equation. So if I ask for the model, I'm asking you to find this a and b and plug them back in to give me what the equation would be. Okay, so I want you guys to try 9 and 10. Put the first values in L1, those are all your x values. Put your y values all in a column in L2. Then do, for exponential model, you're going to do exponential regression. And when you plug it in and get your values, you should end up with y equals 17.56 times 0.913 to the x. And on the power model, plug in your x values into L1, your y values into L2. But this time you do a power regression. And that result should be y equals 7.92 times x to the negative 0.768. Okay, and that's the end of the notes for this unit. So then you're going to work on your homework. The homework that's assigned for this is page 533, 11 through 14, and 23 through 26. Okay, work on going through the notes together, talk through it together, make sure you fill in each other's holes in the notes, and then you can work on the homework together. If you get that finished, then work on your EOC practice, your practice assessments, because those are due Monday night. We will review on Friday. You guys will have a test. Your Unit 7 test is going to be on Monday. Don't forget that. It's been fun. I miss you guys. I can't wait to see you on Friday.